Now we are going to see question 3, Tutor 8.2 and 8.3. Consider the reactions A produces B plus C. Okay, sketch a Maxwell-Boltzmann distribution curve to show the effect of temperature on the rate of reaction. Okay, now kita nak sketch Maxwell-Boltzmann distribution curve. Okay, kita tengok So I hope everyone can draw together with me. Y-axis. And then we have x-axis. Okay. So y-axis is number of, I forgot. This is question A. So this is number of molecules. Okay, and this is reaction pathway. Okay, reaction pathway. And then we will have two different curves. Curve number 1, narrow and tall. Okay, curve number 2, short and wide. Okay, I repeat again, short and wide. Okay, like that. So this is T1, this is T2, T2 greater than T1. Okay, temperature T2 greater than T1. Then we have an important line called EA, the activation energy. Boleh setakat ni boleh ikut ke?
Boleh, sir.
Boleh, okay. Kemudian kita kena lorikkan kawasan lah. So I take this one. For T1, this is the area under the curve. Okay, that is T1. And then for T2, this is area under the curve. Can you see area under the curve for T1 and T2? Okay, the yellow color is the area under the curve for T1, the yellow color pen I use, and the red color pen I use is for area under the curve for T2. And bear in mind that T2 is greater than T1. Okay, remember T2 menunjukkan suhu dia lebih tinggi daripada T1. Dapat lukis ke? Cuba tengok. Kalau tak faham boleh tanya. Okay guys, shall we proceed? Okay, so we go to B. Okay, question B, they ask, explain the curve by relating it to the collision theory. So we have to explain the Maxwell-Boltzmann distribution curve using the relating it to the collision theory. Okay, Maxwell-Boltzmann diagram yang kita lukis tadi tu, kita kena kaitkan dengan collision theory lah. Okay, so start with the first point. We can talk about the diagram. The diagram above shows Maxwell distribution curve for two different temperature, right? So Maxwell Boltzmann curves for two different temperature of T1 and T2. Okay, we explain the what we call the statement T1 and T2. Okay, T2. Okay, and then as usual lah, kalau Maxwell-Boltzmann, kita kena terangkan area shaded, shaded area, Kita kena terangkan shaded area under the curves. Okay. So shaded area under the curve represents molecule having kinetic energy. Okay, area under the curve, shaded area under the curve menunjukkan reacting molecules having kinetic energy greater or equal to activation energy. Okay, shaded area under the curves represents reacting molecules having kinetic energy equal to or greater than activation energy. So what happened then? You can find the T2 area. T2 area is larger or bigger than T1 area. Okay, area shaded for T2 is greater or larger, bigger than area shaded for T1. Meaning, we can say here more molecules, right? More molecules at T2. Okay. More molecules at T2 having kinetic energy equal to or greater than activation energy. That means if more molecules at higher temperature having kinetic energy equal to or greater than activation energy, that means we will have more effective collision. First, we will have more collision. Second, we will have more effective collision. So, conclusively, if more effective collision, secara kesimpulannya, kalau pelanggaran berkesan tu lagi banyak, maka kadar tindak balas juga akan bertambah. So, rate of reaction will increase. Okay. So, saya ulang balik untuk soalan B ni. Pertama, anda kena beritahu Maxwell-Boltzmann curve ini adalah untuk dua suhu yang berbeza, iaitu T1 dan T2. Kemudian kawasan berlorik di bawah graf, shaded area under the curve, okay, menunjukkan kinetic energy of molecules is equal to or greater than activation energy. Okay, area shaded under the curve menunjukkan kinetic energy reacting particles adalah equal to or greater than activation energy. And then kita kena beritahu T2 areanya lagi besar daripada T1, menunjukkan more molecules at T2 having kinetic energy equal to or greater than activation energy. Kalau ada more molecules, maka more effective collision, maka kadar tindak balas juga akan bertambah. Then we go to question C. Next slide. Okay, question C. Next slide. What would happen to the EA value if catalyst added to the mixture? Mark the new EA on the axis and comment on the rate. So, ada beberapa soalan di sini. Soalan pertama adalah, what would happen to the EA value if catalyst is added? Mungkin nak jawab soalan pertama ini, kita tengok graf dululah. Kita nak mark EA yang baru. Okay. So, saya pergi graf tadi, slide number berapa? 5. Okay. So, EA yang pertama saya letak ni, saya label sekali lagi, saya tukar. Saya panggil EA without catalyst. Okay, EA without catalyst. Itu adalah tanpa mangkin. So, kalau ada mangkin, mana kita nak letak EA? Lebih ke kiri ke kanan? Kiri, very good. So, saya pilih satu EA, contoh. Ini, ini skala. So, kita kata EA prime, boleh? We label as EA prime. EA prime adalah with catalyst. Okay, AA prime EA prime adalah with catalyst. So balik kepada soalan C tadi, soalan pertama C tadi. Kita tengok soalan pertama C. What would happen to the EA value if catalyst is added? So kita kata if a catalyst is added, EA will increase or decrease? What do you think?
Decrease.
Decrease, very good. Decrease, okay? Berkurang, Tu yang pertama lah. So what would happen to the EA value if a catalyst is added to the mixture? If a catalyst is added, EA will decrease. And then mark the new EA value on the axis. Kita dah mark. Comment on the rate. What we are going to comment on the rate? Kita kena comment, First, kita boleh cerita function lah. Function of catalyst, Function of catalyst lah. Kita boleh bagi tahu. What is the function of catalyst? So, any idea? Anyone know what is the function of catalyst? The keyword for function of catalyst is catalyst. First, it provides an alternative pathway. Pathway. Okay. First, I write again. Sorry. Provides an alternative pathway with lower activation energy. This is the function of catalyst. Catalyst provides an alternative pathway, laluan alternatif dengan tenaga pengaktifan yang lebih rendah. Okay. Then baru kita cerita point yang kedua. More molecules will have kinetic energy equal to or greater than activation energy. Okay. Then macam biasa, more effective collision occurs, and then reaction rate increases lah. Reaction rate increases. Boleh? So saya ulang balik. Kalau kita tambah catalyst, maka EA kita akan rendah lah. Kurang. EA kita kurang. So bagaimana ini berlaku? Catalyst atau mungkin dia beri laluan alternatif dengan tenaga pengaktifan yang lebih rendah. Provides alternative pathway with lower activation energy. Okay. And then disebabkan itu, more molecules akan ada mempunyai kinetic energy yang lebih besar atau sama dengan tenaga pengaktifan EA. Ini menyebabkan more effective collision occurs dan seterusnya reaction rate meningkat. Okay, so maybe katakan kurang jelas ke apa, you boleh tengok balik video ni lah. Memang saya rekod dan kejap lagi saya akan upload lah. Okay, so that's all for question number 3 tutor.